Hello students, I welcome you back to your own channel Akashwani classes. I hope you all are fine there. In the last video we started the first chapter of mathematics class 9, and that is number systems. In that video we covered the natural numbers, the whole numbers, the integers and the rational numbers. Continuing that same chapter, in this video we are going to see the next topic. We completed exercise 1.1 in the last video, and now the first topic that we are going to cover today is irrational numbers. Okay, so starting with the definition of irrational numbers. So here you can see on the screen the definition for irrational number is that a number is called irrational if it cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. Those numbers are called as what? Irrational numbers. So here you will find out that this definition is quite similar to the definition of rational numbers, but exactly the opposite. Irrational numbers cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. So it clearly states that those numbers which are not rational will be called as what? Irrational numbers. I repeat it again, those numbers which are not rational numbers will be called as what? Irrational numbers. Okay, so take out your notebook and your pen and note down the definition written on the board for irrational numbers, and then we note down some examples for irrational numbers, and examples are root 2, it is an irrational number. Root 3, it is an irrational number. Root 4, no, it is not an irrational number. Okay, it is not an irrational number. Why? Because root 4 means what? 4 is a perfect square, my friend. 4 is a perfect square. So root 4 will change to plus or minus 2. Okay, the value of root 4 is plus or minus 2, because 4 is what? 4 is a perfect square which will turn into plus or minus 2. So no, it is not an irrational number. Why root 2 and root 3 are irrational numbers? Because 2 and 3 are not perfect square. The root will be there. If we find out the value of root 2 or root 3, we will get in decimal, that we will see later on in this chapter. But if a number is in root and that number is a perfect square, that will not be called as what? An irrational number. Clear? So root 5 can be called as an irrational number, root 6 can be called as an irrational number, because 6 is not a perfect square. Okay, but root 9 is not a irrational number, because root 9 is equals to plus or minus 3. Clear? Other form, pi. Pi is also an irrational number. Okay, then we will see 0.10, 1 double 0, 1 triple 0, 1 4 times 0, and so on. This number is continuing, in which the 0 is increasing after 1 by 1 unit. Okay, this number will also be considered as irrational number. We will see the reason exactly why, how to find out the irrational number in the decimal form. Okay, so this is the definition and the examples for irrational numbers. And one fact you have to note down, that there are infinitely many irrational numbers. All the numbers we saw till now were all infinite, were all unlimited, natural, whole, integers, rational as well as irrational number. All the numbers are infinite. Okay, so here now we will see what are real numbers. What are real numbers? And the symbol for real numbers is capital R, and this is the biggest set which we will see till now. Okay, the real numbers include what? The real numbers include all the rational numbers, and all the irrational numbers. Okay, we clearly know the difference now between rational and irrational. Rational is those which can be written in the form of p by q, and irrationals are those which cannot be written in the form of p by q. Okay, and when we combine these two sets, we get the complete set, and that will be called as what? The set of real numbers. Okay, and now if I draw a line here, number line, putting 0 at the center. On the right side I start with positive numbers like this, and on the left side negative numbers like this. This is called as the number line. This is called as what? The number line. Okay, because it is a line containing numbers. Very simple. It is a line containing numbers, so hence it is called as what? Number line. But this line contains all the numbers. All the numbers means all the real numbers. All the real numbers means all the rational as well as irrational. All the numbers are here on this number line. We have written few, but between these two numbers are also there are infinite numbers. Every point on this line represents a real number. The fact is simple to understand, that all the points on this number line, very close points, all different points represents what? Individual point represents what? A unique real number. And hence this is also called as the real number line. This line is also called as what? The real number line. And it is very clear that why it is called as real number line, because every point on the number line represents a unique real number. Okay, so make one thing clear here now before we start example number 3, is that we saw natural numbers, we saw whole numbers, that is starting from 0, natural numbers start from 1. Okay, we saw integers which includes all the negative, all the positive, 0. We saw rational which can be written in the form of p by q, irrational which cannot be written in the form of p by q, and all these numbers combinedly called as what? Real numbers. Okay, and this line is called as what? Real number line. Alright students, now let's start now let's start example number 3. Alright, so example number 3 is locate root 2 on the number line. Now you all know that root 2 is an irrational number. Okay, and we have to show it now on the number line. So to show this kind of irrational number which are in root, we have to use a theorem which is called as Pythagoras theorem. Okay, so before we start example number 3, understand here what is Pythagoras theorem. So you must be knowing also, but maybe some students must not be knowing. So understand that Pythagoras theorem is valid for right triangle. Okay, only for right triangle, means those triangle in which one of the angle is 90 degree. Okay students, 90 degree. So let's say I make a triangle here in which this angle B is equals to 90 degree. You can see it is perpendicular to each other. So this is right angle. Okay, so now the side opposite to 90 degree, it is called as what? Hypotenuse. This will be called as what? Base. This will be called as what? Base of the triangle, and this particular vertical line will be called as what? The height of the triangle. Okay, the height of the triangle. And what is Pythagoras theorem? Pythagoras theorem is hypotenuse square, the square of hypotenuse is equals to base square plus height square. Very clear, very simple. That is hypotenuse square is equal to the base square plus the height square. That is what called as the Pythagoras theorem. So if we look sidewise, so it will be hypotenuse means AC square is equals to BC square plus AB square. Now the one thing you have to clear that on the left hand side, of equal to, there must be only hypotenuse square. This can be interchanged, means if you write height square plus base square, then that's okay, but first side, which should be on the left hand side, must be your hypotenuse. Okay, so applying this to locate root 2 on the number line, follow the steps. So you have to take ruler and a compass to show root 2 on the number line. Okay, so get ready. So first you have to draw a number line, because we have to show root 2 on the number line. So here I am drawing a line. Okay, now I will take bigger scale here to show the numbers on the number line. Okay, so that I can clearly show where is root 2 on the number line. So I will not take 1 centimeter scale, I will not leave 1 centimeters gap between two numbers. I can choose a bigger scale. Okay, you also can choose a bigger scale. You can take one scale equals to 2 centimeter or 3 centimeter, it is up to you. So here I will mark the points. I will write this is my origin on the right side 1, this is 2, and this is what I am saying, that it is up to you what distance you want to keep between two numbers, 2 centimeter, 3 centimeter, whatever. And will mention here your scale we have taken is, let's say 1 unit. This 1 unit is equals to, let's say 2 centimeter. 2 centimeter. This is 2 centimeter. This is 2 centimeter. Okay. Now here at 1, I will draw a perpendicular line. I will draw a perpendicular line, and this is, let's say this is this point at 1. I will name it as point A. At the top it is B, and this AB is also 1 unit. 1 unit is equals to what? That means 2 centimeter vertical. Okay, making 90 degree here, 90 degree here. And now I will join O and B. I will join O and B. So as a result, I got a right triangle here, in which angle A is 90 degree. So here I will write, in triangle OAB, my angle A is equals to 90 degree. And if it is 90 degree, I can use which theorem? Pythagoras theorem, which is completely for right triangle. So I will write, by Pythagoras theorem, applying that theorem here, hypotenuse square first. Hypotenuse means what, my students? Hypotenuse means opposite to 90 degree, and opposite to 90 degree you can see which side is there, OB square. So I will write OB square equal to, the remaining two sides are OA square plus AB square. So OA square plus AB square. Out of these three values, I don't know what is OB, but I know what is OA, that is my 1 unit, and AB also 1 unit. So I will put OB square as it is, OA 1 square plus AB 1 square, that will give me 1 plus 1. OB square equals to 1 plus 1. 1 square is 1, 1 square 1, 1 plus 1 you will get 2. And now to remove this square from OB, I will take the square root on the right side. As a result, I will get OB is equals to root 2. Okay, OB equals to root 2. So as it was 1 unit, this was your 1 unit, I got OB is equals to root 2. The length between O to B is how much? It is root 2 units. Now I will take compass. So you all also take compass. This is my compass ready. And now what you have to do? You have to take this needle point on O. Okay, locate carefully needle point on O and this pencil point will go at B. Okay, and from here draw a arc to intersect the number line. That's it, to intersect the number line. So this was OB was our radius, so we made this arc taking O as the center. So the distance between O to B will be equal to the distance between O to this point, and let's say we name this point as P. So if OB is root 2, how much will be OP? OB and OP are equal, right? So OP is also root 2. So here we show the root 2 on the number line. Okay, now we'll write here that this step what we did here, that taking O as center and OB as radius, draw an arc intersecting what, my dear students? Intersecting the number line at P, intersecting the number line at point P, and then point P represents which number? It represents root 2. So here this is how we have to show root 2 on the number line using which theorem? Pythagoras theorem. Going for the same type of question, the fourth example, locate root 3 on the number line. Locate root 3 on the number line. So note down this. Okay, now I am going to erase and going for example number 4. Alright, so I have not erased the construction which I have already did here for root 2, because this construction is going to help me to find out the root 3 as well on the number line. Alright, so first you have to follow the same steps which you did for root 2 to find out root 2 on the number line, and then we have to add something in this to find out root 3 on the number line. Alright, so now whatever number we are given, to find out, to locate that on the number line, first of all what you have to do in the rough part is that, let's say in the previous example it was root 2. So first I will break 2 into two natural numbers. I will find out two such natural numbers, by adding which I will get this number 2. So that is, for 2 there is only one possible way to make 2, and that is 1 plus 1. 1 plus 1 is equals to 2. There is no other way to make 2 by adding two natural numbers other than this. And here 1 and 1, this both are perfect square or of what? Itself 1 only. These two numbers are, 1 is a perfect square of 1 only. So I choose the unit of taking OA as 1 unit and AB as 1 unit. And as a result, by using Pythagoras theorem, I will get OB as root 2. Clear? Now in the case of 3, if I see, what are the possible ways of making 3 by adding two natural numbers? Let's say 1 plus 2. 1 plus 2 gives what? 3. 2 plus 1 also 3, but 1 plus 2 and 2 plus 1, there is no difference, they both are same. So for 3 also there is one only possible way, and that is 1 plus 2 to make 3 using two natural numbers. Now here we can say this is the only way, this is the only possible way for making 3. Now for 1, we know that 1 is a perfect square of 1 only, 1 ones are 1, but 2 is not a perfect square. So that means if we take the square root of 2, it will be equals to root 2. It is the square of root 2. So that means one side we have to make a right triangle in which one side will be equal to 1 unit and the other will be equal to root 2 units. Okay, as in this case we took the two sides of both 1 unit to get root 2 as the hypotenuse. For 3 we have to make a right triangle in which one side will be equal to 1 unit and the other side will be equal to root 2 unit. That is the only possible way. So here we have already this OB is equals to root 2 unit, that is the required one side is satisfied. Now another side we have to take as 1 unit which will be perpendicular to OB. So what you do after completing this match of steps of root 2, from B you make a perpendicular. You make a perpendicular at B like this, okay, and name this point C. This BC will be 1 unit, and at 1 unit means what? The same thing, 1 unit means we have taken here 2 centimeter, let's say, and join this C with O. Okay, this is our root 2, this is our 1 unit. Okay, and now this is 90 degree here, so we'll write in triangle OBC angle B is equals to 90 degree. Okay, so student, applying Pythagoras theorem, by Pythagoras theorem, what we can write? We can write the hypotenuse opposite to 90 degrees OC. OC square equals to the other two sides are OB square plus BC square. Putting the values, OB is root 2 square plus 1 square, OC square is equals to root 2 square is 2 plus 1 square is 1, and therefore OC square, root 2 square is 2. How? Because this root and square will get cancelled. So 2 plus 1 you will get 3, and when we take out the square from here we have to take root on the other side. As a result we got OC is equals to 3 units, root 3 units. So my OC is root 3. This step we don't have to do for root 3. And now in the same way we will take the compass. Where? Tell me where you will put this needle point. At the same place O, but this pencil point will go at C. So you have to take radius from O to C and draw a arc intersecting the number line, and it will intersect somewhere before your 2 on the number line. So this point is representing what? Our root 3 on the number line. So in the same we will write that taking OS center and OCF radius, draw an arc intersecting the number line at P, and this point P represents root 3 on the number line. So this is how you have to show root 2 and root 3 on the number line. Please like the video if you are understanding the concept which I am explaining to you, and I am taking more time to explain these topics in order just to make you understand. That is the main motto of making this video. So also it will be very easy for me to understand if you comment and let me know that whether you are understanding the concept or not. Alright, so after example 4 we will start now exercise 1.2. Okay, so here on the board I have written the first and second question of exercise 1.2. The first question is state whether the following statements are true or false. So based on the knowledge which we saw before we start this exercise, the answers we have to give, okay, in these questions, whether the statements are true or false, and we have to justify the answer. We have to give reasons for the answer. The first question is every irrational number is a real number. We saw that a real number is a set combination of rational and irrational numbers. Alright, real numbers, rational and irrational. So based on this classification, we can answer this, that it is written every irrational number, yes, is a real number. Yes, all the irrational numbers, set of irrational numbers will be in the category of real numbers. So here I am writing the answers. First answer is, the statement is true because real number comprises all rational and irrational numbers, As a result, the statement is true. The second question is, every point on the number line is of the form root m, where m is a natural number. So every point on the number line, so this is the number line, okay, where if I take any point on the number line, I can represent in the form of root m as per this question, and m should be a natural number. So if I take 1, I can write 1 as root 1 in the form of root, okay, the square root of 1 can be 1. If I take 2, I can write 2 as root 4, okay, because 2 square is 4 and root 4 will be equal to 2. 3 can be written as root 9, where all this number 1, 4 and 9 are natural numbers, alright. But if I take a number 1 upon 2 on the number line, okay, let's say 1 upon 2 means half, 0.5, here is 1 upon 2 on the number line, and if I try to represent in the form of root m, I can write it as 1 by 4. The square root of 1 is 1 and the square root of 4 is 2. So I can write 1 upon 4. But you can see that 1 upon 4 is not a natural number. So because of this reason, we can write the statement is false, because we will show the example of this, that is 1 upon 2 is equals to root 1 upon 4, where one upon 4 is not a natural number. Okay, so the third question is, every real number is an irrational number. We saw in the first question only, that is every real number is categorized into rational and irrational number, right? So every real number is an irrational number. No, it is not just irrational number, it is also rational number, which are different than irrational numbers. So the statement is false, because real numbers also consists rational numbers which are not irrational, Okay, so the answer number 2 now, the answer number 2 is, are square roots of all positive integers irrational? No. Square root of all positive integers are not irrational. Let's understand why. Positive integers means what? Integers, you know, positive numbers, negative numbers, including 0 as well. But if I say positive integers only, it means nothing but the set of natural numbers only. Positive integers means natural numbers, 1, 2, 3 and so on. So if I take the square root of any natural number, will I always get irrational number? No. Root 1 is itself 1, which is not irrational. Root 2 is irrational. Root 3 irrational. Root 4 rational, because root 4 is equals to 2. So the square root of all positive integers are not irrational? If not, give an example. So example we will give, that is root 1, let's say 1, root 4 equals to 2, root 9 is equals to 3. Okay, all these are examples in which we have taken the square root of positive integers and which are not irrational. Okay, so moving to question number 3 now. So question number 3 is show how root 5 can be represented on the number line. So in the same way as we did root 2, root 3 also in the example part, we will show how we can show root 5 on the number line. So I told you to first do some rough work to find out two natural numbers. So let's say 5, if we break into two natural numbers, we can write 1 plus 4. Other than this, there are options 2 plus 3, that's it. Okay, 3 plus 2, 4 plus 1 is the same thing. And from these two options, which options we will select? We will select that option in which we are getting both the numbers as perfect square. Okay, both the numbers are perfect square. Here we can see that 2 and 3, both the numbers are not perfect square. 2 is also not a perfect square, 3 is also not a perfect square. No, but 1 and 4 are both perfect square. 1 is itself the perfect square of 1. Okay, sorry, 1 square, and 4 is the perfect square of 2. Okay, 2 square is equals to 4. So we will select this 2, that is we will draw a triangle in which one side will be equal to 1 unit and the other will be equals to 2 unit. So first draw a number line. Origin 1, 2, okay, and here this time my A will be at 0.2. Okay, because 1 unit I have to, one side I have to take 2 unit. So here is my base is 2 unit, and a vertical line I will draw at 0.2 which will be of 1 unit. So this is A, this is B, and this is 1 unit AB, and O to B is 2 units, and my 1 unit is equals to 2 centimeter as we took in the example part. And now join O with B. Okay, and here it is a 90-degree right angle triangle. So we'll write in triangle OAB, angle A is equals to 90 degree. So applying the Pythagoras theorem. So by Pythagoras theorem, now we have to see which side is opposite to 90 degree. Opposite to 90 degree here is OB. So we'll write here OB square equals to the other two sides are OA square plus AB square. Putting the value of OA as it is 2 unit, 2 square, AB is 1 unit, 1 square, and we know that 2 square is 4, 1 square is 1, OB square equals to 5. To remove the root square, we take the root on the other side, we get root 5. So we got O to B, it is equals to root 5, as we got before root 2 and root 3. Now nothing, take the compass, taking O as the center, and till B we have to take the radius, mark an arc on the number line, and name that point as what? P, and this P represents what? This P represents root 5. So here we will write that taking O as center and OB as radius, draw an arc intersecting the number line at P and point P represents our root 5. Alright students, so this is what we will complete the video today here. Exercise 1.2 is completed. I know the videos are quite lengthy, but I have tried my best to explain each and topic, taking the time in such a way that every student watching this video understand it. I hope you understood, and we'll see you next time in the next video where we will continue exercise 1.3. Till that time, keep studying and ask questions in the comment section if you have any query. Thank you so much. Keep supporting. Bye.